Hello and welcome back. In 7.6 we get to play with double angle and half angle formulas. So we'll start by recalling something from a previous section. Sine of alpha plus beta was sine alpha cosine beta, and we just followed with the same sign and switched them up. Sine of beta, cosine of alpha. We're going to let alpha and beta be the same then. So then sine of alpha plus alpha is sine alpha cosine alpha plus sine alpha cosine alpha. So sine of 2 alpha is 2 sine alpha cosine alpha. Also recall from a previous section, cosine of alpha plus beta was cosine alpha cosine beta, and we flip the sign and do sine alpha sine beta. Again, we're going to let alpha equal beta, so cosine of alpha plus alpha is cosine alpha cosine alpha minus sine alpha sine alpha. So cosine of 2 alpha then is cosine squared alpha minus sine squared alpha. And we can use our identity, one of the first trig identities, cosine squared theta plus sine squared theta equals 1, to do different versions of this last one. So cosine of 2 alpha we can say is 1 minus sine squared alpha minus sine squared alpha, which is then cosine of 2 alpha is 1 minus 2 sine squared alpha. We can do the same thing, just swap out the sine instead of the cosine. Cosine of 2 alpha is cosine squared alpha minus the quantity 1 minus cosine squared alpha. And just do a little cleanup on that one. So cosine squared plus cosine squared is 2 cosine squared alpha, and then the minus 1. So a little bit of an application there. Suppose cosine theta is 5/13, and theta is on the closed interval 3 pi over 2 pi. So in other words, we're either in Q3 or on the positive x or negative y axes. Do cosine of 2 theta, sine of 2 theta under those conditions. So first off, we'll do just our little sketch. I'm going to leave us more room in Q3 just based on the restrictions they told us. And they told us also that we had 5/13, so we had a hypotenuse of 13. X value, we're in Q3, so positive 5. So we know our y value is going to be negative. So we have y squared plus 5 squared is 13 squared, or you may also already have recognized it as a 5, 12, 13 triangle. Mth169 minus 25, so y squared is 144. So y is plus or minus root 144. And because we are in Q3, we want the minus, so y is negative 12. So this tells us that the sine of theta is negative 12/13. So we want the cosine of 2 theta and we want the sine of 2 theta. So cosine of 2 theta is 2 cosine squared theta minus 1. That's one of the versions that we had. So 2 cosine, or cosine of 2 theta is 2 times 25 1/69 minus 1, so original cosine value squared there. So 50 1/69 minus 1/69 1/69, so we're at negative 119 1/69. So that answer is problem 1. Problem 2, finding sine of, I should put a comma in there so you know I'm not asking in this one for a product. Without that in between, we'd be asking for a product. This one we're just asking for it separately. So sine of 2 theta, recall it was 2 sine theta cosine theta. So sine of 2 theta, 2 times sine of theta was negative 12/13. Cosine of theta was given as 5/13. So let's see, negative 120 1/69. And of course, you can confirm for yourself. It's been the video time on it, but you have 2 other options you could have used for cosine of 2 theta. You could have done cosine squared theta minus sine squared theta and gotten the same answer. You could also have said cosine of 2 theta was 1 minus 2 sine squared theta and gotten the same answer. So I'll ask you just to confirm those for yourself. Alright, so then we'll develop the tangent of 2 theta formula. So tangent of 2 theta, first clear choice would be just sine of 2 theta over cosine of 2 theta. And then we just use a little bit of substitution. If we don't know sine and cosine, but we do know tangent, we would go another route then. We'd go with what we know about the tangent of alpha plus beta. Well, that, if you recall, was tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So this is, again, if we don't know the sine or cosine, but they do give us some information on the tangent. So like before, we will let alpha equal beta. So tangent of alpha plus alpha, we'll shorten that down to 2 alpha, is tangent alpha plus tangent alpha over 1 minus tangent alpha tangent alpha. So that's 2 tangent alpha over 1 minus tangent squared alpha. That is one ugly alpha there. Nevertheless, it is a valid formula. Another thing they have us do is sort of rearrange to make, they call it a new formula. I don't know that I would call it a new formula. Cosine of 2 theta. Recall one of the versions was 1 minus 2 sine squared theta. It can be very helpful in your calc and diffie Q courses to reduce the power on something. So it's very handy to have that square by itself and to be able to write it the other way. So then 2 sine squared theta is 1 minus cosine of 2 theta. So we just added that to both sides, subtracted that on both sides. So then we'll cut it in half, and sine squared theta is half minus cosine of 2 theta over 2. So again, really not a new formula, just a rearrangement, but this version is quite handy later on. And you could do that with either version of it. Cosine of 2 theta, recall, also was the 2 cosine squared theta minus 1. So cosine of 2 theta plus 1 is 2 cosine squared theta. So cosine squared theta is half plus cosine of 2 theta over 2. So again, those are very, very handy in later coursework. They're useful in this class too, obviously, since we'll be asking you questions on it, but it is a very useful tool later on as well. We can do a sort of an extension, then tangent squared, how to reduce that. So sine squared over cosine squared. And we can use our power reducing. So half minus cosine of 2 theta, over 2. Got a little wild there with my fraction bar. Half plus cosine of 2 theta over 2, and you can just multiply top and bottom by 2. And tangent squared theta then is 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. So then they have us using some of the properties to solve equations. So they have us solving sine of 2 theta is worth the same as cosine theta, and we want theta to be on 0 to 2 pi inclusive and exclusive respectively. So sine of 2 theta, recall, is 2 sine theta cosine theta. It's equal to cosine of theta, and we can just set that to 0 and factor. So 2 sine theta cosine theta minus cosine theta is 0. Cosine theta by 2 sine theta minus 1 equals 0, so we pulled the common factor. So either cosine theta is 0 or 2 sine theta minus 1 is 0. So cosine is 0 at pi over 2. Theta is also 0 at 3 pi over 2. And we stuck to one spin around the unit circle. So sine of theta is 1/2, so we added 1 and divided by 2. Sine theta is 1/2, excuse me, at pi over 3 and 2 pi over 3. or I'm sorry, pi over 6, my apologies. I was picturing root 3 over 2 for sine theta for some reason, pi over 6, and then 5 pi over 6. Not sure why I was picturing a 60-degree angle there. So you can either use the unions for that, or you can use the set notation. So we have pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. Alright, so the next thing we build are the half angles. So recall sine squared theta is half minus cosine of 2 theta over 2. And we're going to let theta equal alpha over 2. So then by substitution we have sine squared of alpha over 2 is worth half minus cosine of, my apologies, I didn't mean to mix and match here. We'll do both of those guys as thetas. So we have 2 times theta, which is 2 times alpha over 2. Over 2, so sine squared alpha over 2 is half minus cosine theta alpha, my apologies, cosine alpha over 2. So the over 2 is not part of the argument there. So I would ask you to try the similar process with cosine squared theta. See if you can develop a similar formula for the half angle. Okay, welcome back. Hopefully you paused it, gave that a run. So cosine squared theta, remember that was half plus instead of half minus. Cosine of 2 theta over 2. And similarly, we'll let theta equal alpha over 2. So cosine squared of alpha over 2 is half plus cosine of 2 times theta is 2 times alpha over 2, which is alpha. And then the bottom of the fraction bar comes along. Yeah, we can do a similar thing for the tangent squared theta. Tangent squared theta was 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. So just the sine over the cosine and clear the fractions. So if we want the tangent squared of alpha over 2, then we have 1 minus cosine alpha over 1 plus cosine alpha. So we can either leave them in this form, or we can do the square root of each of them and say that, for example, the sine of alpha over 2 is plus or minus square root of a half minus cosine alpha over 2. Cosine of alpha over 2 plus or minus square root of a half plus cosine alpha over 2. Again, both of these over 2's are not part of the argument. It's saying the entire numerator is over this denominator of 2. Similarly, tangent of alpha over 2 plus or minus root 1 minus cosine alpha over 1 plus cosine alpha. So we can use those to find some exact values of things that are not nice, neat, pretty, either 30, 60, 90 triangles or 45, 45, 90 triangles. So if I want the cosine of pi over 8, I know that that's the cosine of half of pi over 4. You don't have to have this a little bit smaller. You can just write it as half times just regular size pi over 4. I just wanted to sort of emphasize that this is kind of our alpha then. So that's our alpha over 2 format. So then cosine of alpha over 2 plus or minus pi over 8 though. Pi over 8 is in quadrant 1, so plus. So we wouldn't need the minus. So cosine of pi over 8 then is worth the plus of it. So half plus cosine of pi over 4 over 2. So cosine of pi over 8 is then square root of half plus root 2 over 4. So root 2 over 2 divided by half is root 2 over 4. Alright, so a little bit more of finding some other values using the properties that we've learned along the way. So we're going to find sine of theta over 2, cosine of theta over 2, and tangent of, drew so many alphas today, tangent of theta over 2. We're going to stick to 1 revolution. So given the information, cosecant theta is negative root 5, and cosine theta is less than 0. So cosecant, remember, that's a relative of the sine. It's just the reciprocal of the sine. So if the cosecant is negative, so is the sine. So this tells me I'm in either quadrant 3 or quadrant 4 or the negative y-axis. The fact that it's not negative 1 would tell me it's not on the negative y-axis precisely. The fact that they said cosine theta is negative tells us that it has to then be quadrant 3. Cosine theta is negative in quadrants 2 or 3. The overlap is quadrant 3. So 1 over sine theta is negative root 5. So sine theta is equal to 1 over negative root 5. Of course, I don't want to leave that negative in the denominator since I know that that's not a reasonable length of a radius. And we can rationalize that as well. So negative root 5 over 5 in Q3. So I'll make my drawing. So our radius is 5, our y value is root 5 in the negative direction. Our x value is also going to be in negative because of where we are. They told us cosine was negative. So x squared plus root 5 squared, which is 5, is equal to 5 squared, 25. So x squared is 20. So x is root 4, root 5, so 2 root 5, and in the negative direction. So that lets me find the, we had the sine, we can find the cosine from that. Cosine of theta then, negative 2 root 5 over 5. And we can get our tangent off of those two then. Sine over cosine, negative root 5 over 5 over negative 2 root 5 over 5. Drop those denominators and we have negative over negative is a positive, so root 5 over 2 root 5, which is 1/2. So our tangent is positive 1/2. Alright, so sine of alpha over 2. Theta over 2. My apologies, now I'm even saying it. Usually we would do the plus or minus. We know, however, that our sine is negative. So negative square root of 1/2 minus cosine of alpha. So cosine of alpha over 2. Theta over 2. So sine of theta over 2. Negative square root of 1/2 minus, and then half of the cosine. So half of negative 2 root 5 over 5. So basically the 2's will drop. So minus negative root 5 over 5. So sine theta over 2. So negative square root of 1/2 plus root 5 over 5. So see if you can find the cosine of theta over 2 and the tangent of theta over 2 on your own. If you get stuck, we can go through it in the Q&A section next time. So some problems to try out in 7-6. I would try 9 to 79 on the odds. Or I'll do the equivalent My Math Lab thing as well. If you have any questions, please reach out. Otherwise, I will see you next time. Thank you.